All right, everybody, I want to take a moment and talk about Newton's laws, and this is a little bit of a step back, but if you're struggling with this idea, I think it would be helpful to look at this problem. So it says a box lies on a frictionless floor and weighs 40 newtons. A 60 Newton force is applied 15 degrees above the horizontal. What normal force does the floor apply to the box, and what velocity does the box have 2 seconds after it starts moving? So the first thing we want to do is draw a free body diagram. So here's my box. And I've got a weight going down and a normal force going up. And I also have this applied force at 15 degrees. And it's going to have components in the x and the y direction. And they're going to be related by the trigonometric functions with the 15 degrees. So if I come down here and I say, well, what's the sum of the forces in the y direction? Well, that's the normal force plus the y component of the applied force, which is Fa sine 15 degrees, because y is opposite, minus Fg. And that's equal to 0 because I'm not accelerating through the floor or up into the sky. In the x direction, some of the forces in the x direction, all I have is the x component of the applied force. The first part asks me to find the normal force, so to do that, what I'm going to do is I'm going to subtract Fa sine 15 degrees from both sides. And add Fg. And that tells me that the normal force is Fg, the weight, which is 40 newtons, minus the y component of the applied force. So that would be 60 newtons sine 15 degrees. And that is 24.5 newtons. To solve the second part, what I need to do is look at a kinematic equation. So I need to say, well, the velocity is equal to the initial velocity plus at. And I know the initial velocity is 0. So I just need to find a, and then I can use my 2 seconds to solve it. So some of the forces in the x direction is equal to ma, but m isn't given, the weight is given. So the acceleration, which I would normally write as Fa cosine 15 degrees over m, now becomes over the weight, so Fg, divided by g, which is the acceleration due to gravity. So the acceleration A is just equal to 60 newtons cosine 15 degrees divided by 40 newtons over 9.8 meters per second squared. And that gives me 14.2 meters per second squared. Now the velocity is just going to be 14.2 meters per second squared times 2 seconds, which is 28.4 meters per second. And that would be how I would solve this problem.